This is Jeff Allenby. I'm the Director of Conservation Technology at the Chesapeake Conservancy, and I manage our Conservation Innovation Center. I'm joined here with Emily Wiggans, one of our GIS analysts, and we're looking forward today to talk a little bit about building a bridge from monitoring to action, or a little bit more complexly, talking about how we can translate water quality observations that you may be looking at, or habitat or biology, into actionable projects in your watershed to really move beyond just observing what's going on in the natural world to understanding a little bit about the why behind some of that information. Looking at national scale and national challenges, partners across the country are monitoring water for a variety of different things. Some of it out west may be more focused on water quantity issues. Do you have water in the streams? In the east here in the Chesapeake Bay, we're very focused on water quality, looking at nitrogen, phosphorus, sediment rates, looking at water clarity, looking at biological indicators to really measure how healthy the waterways and lakes and streams in the Chesapeake Bay are around us. Regardless of who you are and where you are and what you're monitoring, the real goal for doing that monitoring is to have a better understanding of what's going on in the landscape around you, understanding where you have watersheds or waterways that are improving in health, and critically where you have waterways that may be declining in health, where you may need to focus some additional action. A lot of these efforts are combined with restoration projects, trying to improve your local waterways, restore habitat, restore water quality, or restore water quantity. And what we're going to talk a little bit about today is a pilot that we've been working on in a local watershed with a local partner of ours, but really to help understand some of the why. And like I said, going beyond the water quality data monitoring to really understand the landscape context that we're seeing and showing how we can actually visualize some of the improvements from restoration projects that have gone on, and moving into how we can help our local partners really get a better understanding of their watershed and what's going on in the watershed. Now, if any of you have joined some of the previous webinars that we've put on, or we're going to be putting on additionally over the next couple of weeks, the Citizen Water Science Framework is something that the Water Data Collaborative has come up with to really look at moving from data production to data to action. And over a series of webinars, we're detailing data production and how do you get a standardized research question? How do you get a standardized database of your information to make it more easily shareable and to be able to get it into some of the further steps down the road, but really having kind of your data house in order is the first step. Moving beyond that, really looking at local data storage, how do you make that clean and accessible, as well as some analysis and visualization tools as a way to gain a better understanding of what's going on in your data. And then what we're going to talk about today is really focusing on kind of what you do once you have your data cleaned up and machine readable, how you look at modeling and analysis and how you start to communicate that information to outside partners in a way that is a little bit more comprehensible than a Excel or Access database with a bunch of numbers behind it, which, like it or not everybody likes numbers. And what we're trying to do is really show how you can tell a really compelling story about why water is important and how your data is helping to inform what you're doing in your watershed behind it. So for those of you who haven't heard of us yet, the Chesapeake Conservancy is a regional nonprofit based in Annapolis, Maryland. And our Conservation Innovation Center is a focused effort to really promote the concept of precision conservation, or getting the right practices in the right places at the right scale and making sure they're working. We do a lot of GIS analysis and remote sensing analysis to better understand the landscapes in which we're working. But a critical component is kind of that last piece, making sure they're working. That's really where water data can play a really strong role to be able to show that what we think on the landscape and is working actually is, and it's having the impact that we want it to have. So to talk a little bit about the work that we're doing, kind of a nice example of kind of how you can take water data, combine it with landscape information to get a better understanding of what's going on, we want to talk a little bit about the South River. This is in Anne Arundel County, Maryland. This is right by our doorstep, quite literally. And we are building on an existing relationship that we have with the South River Federation, which is now merged. They're now the Arundel River Federation with 2 other rivers, but you might hear us kind of using the names interchangeably. But we had previously worked with them on kind of the first couple of steps in terms of that kind of cleaning up the databases, standardizing information, and creating some visualization tools. If you go to southriverdata.net, you can see that. But what we really wanted to do is work with them to kind of take their analysis and assessments to the next level to kind of show how combining GIS and remote sensing with some water data can really lead to great information about what's going on. Now, just kind of back to that original slide of all of the different issues that are going on, South River Federation, or South River, the Arundel Rivers Federation, is really conserved around dissolved oxygen levels, bacteria, water clarity. They have a PCB and fish tissue issues, fecal coliform and shellfish, restricted areas, as well as being a part of the Chesapeake Bay TMDL for nutrients, particularly nitrogen and phosphorus in the brackish areas. So at this point, I'm going to pass it over to Emily Wiggans, who's been working a lot on these issues. You know, just again, helping people orient if you're not from the region. Chesapeake Bay watershed is about 64,000 square miles, covering 6 states and the District of Columbia. The South River is kind of right smack dab in the middle of the bay, and is a nice small area. It's about 36,000 acres and has about 246 miles of streams. For our purposes, this was a great test because it's big enough to actually show, you know, kind of the potential of what's going on, but it's not too big of a bite where you're getting yourself in trouble by trying to do too much at once. So what I'm going to do is pass it off to Emily, and Emily is going to tell you a little bit about the work that she has been working on with Arundel Rivers Federation.
All right, thanks, Jeff. So looking at clarity in the South River, the Arundel River Federation monitors for a couple of different parameters, but we decided to focus on clarity because that data was really accessible and they have a lot of records for it. So they measure their clarity with what's called a Secchi disk. If you're not familiar, there's a picture of one in the lower right of the screen. It's basically a black and white contrasted disc, and you lower it until you can't see the contrast anymore, and then you take a measurement of how deep it is. So it's really easy way to get a kind of low-level proxy for how clear your water is. There are a lot more scientific measurement ways you can do it, but it's a standard, and they've got a lot of great data for it. So looking at the tidal sites where the Arundel River Federation monitors, there's a couple up on the screen in the right in red and yellow. Those are all their stations. If you've heard of the EPA's water quality portal, hopefully many of you have, that's how a lot of citizen science organizations and other state and federal level monitoring organizations upload their data to be publicly available. So one of the problems that the Water Data Collaborative is seeking to solve is really making all of the different 21 sites just as accessible as the single site that's on that second picture in the left corner show, you know, the equivalent information. So what story are those 21 sites telling that the EPA single site does not? Our solution to beginning with this process was to use the statistical analysis coding language R. Hopefully some of you are familiar, but generally speaking, some of the benefits are that it's open source and there's a lot of resources and tutorials available online. So like me, if you're relatively new to coding, there are a lot of great quality tutorials out there for you to get started. It's built for statistical analysis in mind. So if you're analyzing something with 3,000 records, Excel frankly often crashed on us. So luckily R is built to handle that amount of data well, and additionally it handles spatial data well, and we are working with GIS-based spatial data at some points, so that was also really important. The USGS actually has what's called a package called data retrieval that allows you to read in data directly from the water quality portal. right into R. So that was super useful in calling exactly what we needed out of the water quality portal right into our analysis. So really, for the sake of looking at all the kinds of scenarios we would see for using this analysis, we envision, some of your organizations may have all of your data up in the WQX. The Water Quality Exchange and the Water Quality Portal are kind of the same thing if you hear me using them interchangeably. One is referred to as uploading and one is referred to as downloading. So some organizations actually use the WQX as a data organization tool. There are some limits to that though, because there is kind of a learning curve into getting your data up there, and there are some standards that you need to meet. So if you do have all your data up there, great for you. You can easily use R to pull the specific data that you're looking to use, to pull that data and quickly analyze it. Like the example we're talking about today, there may be some WQX data in the area that you're looking at and some of your own and citizen science data from the Arundel River Federation in this case. So again, R is a great solution because you can quickly download what may exist for your area from the WQX, or you can also import your own just from a CSV file or from an Excel file and read it in as well. And then again, third scenario kind of is you have all of your own outside data, nothing from the EPA's WQX there. And of course, you can use data from a CSV, read it all in that way as well. So kind of going over the general process that we went over for calling this data in and doing some analysis. The first step in our code was to set up tools that we needed for analysis, so call those specific packages that we needed. And then we wanted to make sure we were specifically grabbing SekiDisk data from the WQP. We already knew the name of the monitoring site from prior data exploration, so we're able to be really specific. There were over 54,000 records for that site alone, looking at other sorts of measurements like temperature and depths and all that. And we only wanted the clarity and SekiDisk data, so we made sure to filter that out to allow for quicker analysis. Then we brought in the South River data from a CSV file, did a little bit of light cleanup for columns that we weren't looking for the sake of this analysis, and formatted the headers to match the output of the WQP data. And then we combined those two data sets together and just did a little bit more data standardization to make sure all your dates are in the same format and stuff like that. And then finally, we plotted the combined data sets. There are many different ways you can plot it in R. R provides so many great packages to visualize just on a basic level and allows for a lot of customization for the different filtering you might need. So looking at some of that, here is one of the first outputs we got, which is all of those stations from that map earlier of the 21 stations. Plus, you'll see on the right the CBP WQX WT 8.1 station. So that's the one out of the WQX. There, that data is highlighted. So again, if you're only considering the data out of the WQX, you're missing so much other data and resources that are out there for looking at water quality in the South River. So that's one of the reasons we really want to make sure this work is done. We today are going to talk about two specific watersheds, and so I've now highlighted those in blue and red, Broad Creek and Church Creek. So looking at those a little bit more specifically. And then again, you can also in R quickly add in trend lines. So again, those are the ones you're going to do. And then down in the lower right, you can see where they are in the watershed relative to the rest of the watershed. And then the next thing we're going to do is kind of take a deeper dive into looking at all of this analysis now that we've done some data exploration. So I'm going to now go through sort of a little ArcGIS Pro model demo that I set up. This is the spatial component of things, so I wanted to quickly show you guys what the inputs were. One of the things that we have is some tree canopy cover. We actually have 3 years of data sets, but this just shown as the 2017 tree cover, and it is at a 1 meter resolution. We have it for a couple of different years. And then we have the 2013-2014 land cover, which is 1 meter in resolution, that the Conservation Innovation Center produced along with a couple of partners. That data at 1 meter resolution actually exists for the entire Chesapeake Bay watershed. We'll make these slides and presentation available. So if you guys are interested in looking at that, we put the URL where you can get it. It's free and it's super useful for analyses like this. The other data set that we looked at in the model is showing some parcel sewer data. So basically what I did was grab the Anne Arundel County parcel data and then filter it out everywhere for the parcels that had listed as private sewers. So that means that they're not on public sewer, probably a pretty good guess that that would mean that they're on septic systems. So those are the inputs of the model. So basically what I have set up is a 2-click solution for you to figure out what's going on in your area. There is a toolbox with ArcGIS that you just quickly input your clicked point for the watershed. So here's Broad Creek that we have in the center of the screen with a little point, and then you type in the name of your watershed. So you just click for a point and you click to type in the name, and then you let the model run. So in the background, what's happening is that the watershed is selected. The areas for the input data sets within the selected watershed are calculated. So those tree canopy cover areas and the total acreage of the watershed as well. Those values are joined back into the original watershed selection. Then you're intersecting the selected watershed with all of the areas that touch a private sewer parcel. So whether it intersects just a little bit or is fully within, we grab that whole data set. And then finally, the area of land cover within that watershed gets outputted to just an Excel spreadsheet. If you're more familiar with GIS and Model Builder, I showed a nice little graphic of the model at the upper left. Certainly not the most complicated model ever, but it does have a lot of moving parts in it. Basically, though, at the end of the day, you just hope that your model runs successfully, which it did, which is great. So now looking at what your outputs are. So what you're going to end up with is the darker green watershed polygon and the lighter green kind of yellow private sewer parcels. So looking at those a little bit more, your parcel-based private sewer output, so now I just have it colored in red, so you can see it pulled all of the parcels within that sub-watershed that are listed as private sewers in the county's parcel data set. So when we were talking to some of the local organizations, the Arundel River Federation and the rest of the Water Data Collaborative, we kind of envisioned that leaky septic tanks are often a huge culprit in bacteria and other nutrients getting into our waterways. So if you can quickly subset all of the areas within a watershed that may be on septic, you could do hopefully some targeted outreach, get involved with, if you're the watershed keeper organization, get involved with a neighborhood or a subdivision's homeowners association or something like that, and just kind of put yourself out there and make sure that people know that they're on septic and know that their septic could be leaking, and really make sure that that's not the source of any waterway impairment. The other output is the polygon of the watershed again. So that's going to have a bunch of really helpful information in it. The first thing is the tree canopy cover in acres from 2007, 2013, and 2017. You can also see in the lower right, we have total areas in acres of the watershed. So you can see how many total acres are lost or gained. The visual results of the tree canopy is also an output. I just don't have that up on the screen right now. And then you also have this nice little Excel output where I just quickly converted to acres what the land cover is like. Again, that's 1 meter resolution land cover that I just have converted to acres. That's super quick output into Excel. And with that, you can do something really powerful like this. So this is just a simple pie chart showing Broad Creek's land cover. The dark green is forested tree canopy areas. The light green is low vegetation. The red is structures, and the gray is imperviousness. So you can see that there's a lot of tree canopy in this watershed. Why does an analysis like this matter? So if you have a couple of different sub-watersheds or even just adjacent neighboring watersheds, you can compare which ones to each other to determine the most need, whether that need is more targeted restoration efforts or more targeted monitoring efforts. And so for an example, I have Broad Creek shown. That's the one that we just ran and looked at. And you can see compared to next door, Church Creek, there's a lot more imperviousness and structures. So in Church Creek, between the imperviousness and the structures, that's about 30% of the watershed. And we know that at just 10% imperviousness, a watershed is negatively impacted. There's going to be more runoff from rainstorms, more urban runoff, resulting in increased sediment and nutrients into the waterways. So Church Creek is a great target for restoration, which, speaking of, the South River Federation and now Arundel River Federation actually has done a ton of restoration projects in the Church Creek watershed as a result. They've done stuff like stream bank stabilization, living shorelines, tree plantings, and stream restorations, which all add up to a much more healthy watershed, hopefully. So looking at the results again of the clarity in the Broad Creek and Church Creek watersheds, I want to point out a few specific things. So we do see this outlier, and we actually confirmed with the Arundel River Federation that it was apparently a really high Secchi disc reading. They had WOW written on their field notes. So though it was confirmed, let's eliminate that extreme outlier and just look at a more fine scale display of the readings over time. So here you can see I adjusted the scale on the y-axis, and now we're only looking at 0 to 2 meters in Secchi disc measurements. So you'll note that the top graph only shows through the end of 2016, and the lower graph shows through the near end of 2018. While it looks like both creeks are doing pretty well on top, extending the record further for the lower graph shows there's actually more of a significant decline in the clarity trend for Broad Creek. So you can see there's a really narrow gap between the trends there and a little bit more of a wider gap there. The majority of the BMPs that I just showed, the restoration projects that were installed in the Church Creek watershed, were put in place in 2017, only to be followed by one of the most rainy years on record in the area for 2018. And though more analysis could certainly be done, it really looks like Church Creek's restoration projects are working and clarity is holding steady. That red line on the lower graph is holding steady the last few years, despite record rainfalls. So now maybe it's time for some restoration in Broad Creek because we're seeing a little bit more of a decline compared to where there were some restoration projects put in. So here is an example of a potential candidate for a restoration project in Broad Creek. So the area to the right of the blue line is within the Broad Creek watershed. And so using free and public data from Global Forest Watch for tree canopy loss, which actually exists at an international level, we identified an area that was developed from 2015 to 2016. That is what's showing in those red and orange raster squares. And the imagery is shifting between a 2005 aerial view and a current aerial view to show that loss in tree canopy. Clearly some sort of development was put in. The change in land cover may have been one of the things that's reflecting in the decline of the Broad Creek clarity. So it could be a really good candidate area to look at putting in a BMP to make sure any runoff from this new development is trapped before it reaches Broad Creek. I'm going to turn it back over to Jeff now to talk about how we are scaling this nationally moving forward.
Sure, thank you, Emily. And looking at it from the perspective of we are not completely done with our project yet. You know, we wanted to get some of this information out. We're working on a couple steps both now and over the next year. One is creating a web app for the analysis. Showed you the link for South River data before. Because we're building these models in ArcGIS Pro that can be published as a geoprocessing service, which makes it very easy for you to dynamically calculate this information on the fly through a web app. So you don't even have to have GIS on your computer. It can be run server side and make that accessible for a whole other suite of people. Also looking at it, you know, expanding it across the country, we are lucky to be in a very, very data rich environment where we can take these deep dives into very high resolution data, recognizing we don't have that data for the entire country or the entire world. I would like to say yet, but you know, we don't have plans for creating a 1 meter land cover data set nationally at this quality yet. Really looking at what other data sets could be applied, whether it's the National Land Cover Database, whether it's other 10 meter data sets or other state data sets. But looking at just creating a story map to help people understand 4 different challenges that you're looking at. What are the different data sets that are available from land cover, watersheds, tree canopy, more? You know, and this is really where we are putting out a call to action for other partners to be able to say, what are the data sets or what are the questions that you are interested in answering? Because what we can do is start to put together some of those resources and help people understand and really build our tools not just based on our local data sets, but on national data sets where it would be applicable to anyone, anywhere. Also looking at kind of our analysis and data integration, Esri has built their R bridge, which makes it easy to combine kind of R scripts within the ArcGIS world, but recognizing not everyone lives in that world. Really what we want to do is kind of streamline the process to be able to get information down out of the water quality portal into an analysis platform to be able to make it as easy as possible for partners to go from, you know, selecting their site to getting kind of information on the back end without having everyone need to be an expert in GIS or R. We also want to be very transparent. So looking at the full, we're going to be sharing the full process, you know, the web apps that we have as an example through Esri's web app builder that you could be applied and customized to a different geography. We have a GitHub repository, and we're going to be posting the code and R scripts on that. We're also going to be making the ArcGIS toolbox that Emily demonstrated available for download. So if you are a GIS user, ArcGIS user, you can get that information and start to get into it on your own geographies, your own issues, your own problems. But really what we want is for people to start using this information to really go beyond their water quality data as a kind of history of water quality observations, and as I said in the beginning, start to answer the question of why. Why are we seeing the readings that we're seeing, the measurements that we're seeing, and really how do we start to inform additional activities throughout the watershed? With that, I want to thank everyone for taking the time. I do see that there's been a couple of questions so far, but want to open up the conversation, answer any questions that we can. And hopefully people found it useful. And as Emily mentioned before, we are hosting recordings of the webinars on the Water Data Collaborative website, pretty simply waterdatacollaborative.org. If you go to the resources tab, we have a button for all of the webinar recordings, and we can make a PDF of the PowerPoint available as well if anyone is interested in kind of following up afterwards. Also included both my and Emily's email addresses. If anyone wants to follow up further about anything that you heard today, feel free to shoot us an email and we'd be happy to talk more and share lessons learned and everything that we can. You know, we see part of our role is struggling through how to make this work, and we don't want everyone to recreate the wheel. We want people to leverage our work as much as possible. So happy to reach out. So with that, we can start to turn to some of the questions. Sam, I don't know if you had a particular way that you wanted to do that, but happy to talk more about that.
Yeah, so if folks want to go ahead, if you have a question you want to ask verbally, you can raise your hand and I'll call you out by name and unmute you. Otherwise, we can work through the written questions that we got as the webinar was going on. So the first question we got, what are some of the ways that we can get involved with local restoration and things related?
Sure, and that question is from Kristen Chitwood. Kristen, is that a question particularly around the Arundel Rivers Federation, or is that generally with watershed groups?
Kristen, we unmuted you there.
Oh, sorry. Just watershed groups, like in general.
Yeah, I mean,
I'm from Richmond, so
okay,
excellent.
I was there over the weekend.
Okay.
Yeah, so the best way to get engaged is in Richmond, talk to partners like the James River Association, talk with the James River Parks Department. There are a lot of opportunities that are going on. We on the Water Data Collaborative website, we have an interactive map that has all of the groups that are doing water quality monitoring across the country. So feel free to kind of zoom in and see who other partners that you may be working with locally are. But my advice on that is to just shoot an email, give them a call. If you want help connecting with the James River Association, let me know. We work with them closely. I actually have an email from them I need to get back to in my inbox right now. But happy to help make that connection on a personal level. But if anyone else is interested in getting more engaged, check out that map on waterdatacollaborative.org. And what that will allow you to do is kind of zoom into your geography and figure out who the local partners are if you don't already know them.
Okay.
All right, moving on. Wayne Webb had asked, flow is important to add to citizen data as cubic feet per second per square mile from most representative gauges. Do you have tools for adding flow?
So at this point, we are not including flow, and recognizing that the South River being a tidal tributary, flow is not the same issue as it may be in more moving water areas, but definitely looking at kind of flow adjusted readings is something that's important. It's something that I think that we have the opportunity to address further. As I think we mentioned in the beginning, we see this as a pilot, as an example of what could be done. And definitely, having those readings and looking at kind of flow adjusted rates is something that could definitely be incorporated into the modeling side of things that Emily showed.
Yeah, and there's definitely a lot of good packages out there. The USGS data retrieval package in R also really works well with all of the stream gauge, pulling the stream gauge data. So we can definitely look at including some resources for everyone to get access to that information as part of this as well. That's a really good point. Thank you. Nicole Rasmussen asked, where can we get the tool for the tree canopy loss? I think what you're indicating was from that little GIF area I showed, and that is from Global Forest Watch. Nicole, you can send me an email and I'll be glad to link you to the site directly. But if you search Global Forest Watch, you should be able to find it as well.
Yeah, that's a program of the World Resources Institute. That's a really, really amazing and strong global data set for forest canopy change. And Rick, thank you for flagging us on that. We will take a look and see what's going on.
All right, last call for questions for folks. You can raise your hand through the webinar tool or type them in. And I'm not seeing any more questions.
Well, like I said originally too, or a few minutes ago, if you do think of anything else or you don't want to raise your hand and ask it in front of a group of other people, feel free to send us an email. We are more than happy to talk more about the work that we're doing, the pilot that we're working on, you know, kind of how we envision it being applied or transferred to other geographies. If you have interest in transferring it to other geographies, let us know. We're happy to share whatever we can and to try to help you get it configured and set up for your area as well. But definitely thank everyone for taking the time today, and hopefully look forward to hearing from some of you soon.